Today, we are diving deep and cracking the code on one of the most fearsome viruses out there, Ebola. We're going to look at how this deadly intruder operates and, more importantly, the brilliant strategy scientists cooked up to build a fortress against it. So, let's get right into it and start by understanding the enemy. First, let's just set the stage here so you understand the stakes. At its absolute worst, the Ebola virus has a case fatality rate of up to 90%. Just let that number sink in. That makes it one of the most lethal pathogens on the entire planet. So you can see why understanding how to fight it isn't just some academic exercise. It is truly a matter of life and death.
You know, to defeat an enemy, you really have to understand its game plan. And believe me, the Ebola virus is a master strategist. It's like the perfect intruder, specifically designed to sneak past our body's most advanced security systems.
So what is this thing exactly? Well, Ebola is a filamentous virus, which just means it's shaped like a thread. It was first spotted way back in 1976 and got its name from the Ebola River in what's now the Democratic Republic of Congo. It's the cause of a horrifying illness called Ebola virus disease, which is a severe hemorrhagic fever. And that's exactly what it sounds like. It can wreck your circulatory system, leading to massive and often fatal internal bleed.
And this isn't some ancient history. It's a very real, very modern threat. Just look at this timeline. Ever since it was discovered in '76, it's popped up again and again, causing these devastating outbreaks. The big one, the 2014-2016 epidemic in West Africa, was the largest in history and a terrifying wake-up call for the entire world.
So, let's get into its attack plan. I want you to think of your body as a high-security fortress. Ebola hasn't just found a way to climb the walls, it's figured out how to get inside and shut down the alarm system before anyone even knows it's there.
Tool number one is its master key. On the surface of the virus is a protein called glycoprotein, or just GP for short. The virus uses this key to latch onto our own cells, and it targets the important ones, like our immune cells and the cells lining our blood vessels. It just clicks, unlocks the door, and lets itself right in.
Okay, so once it's inside, the real sabotage begins. It deploys these two internal proteins, VP24 and VP35. Their entire job is to cut the wires to the body's emergency broadcast system. That system is called the interferon response, and it's how our cells scream for help when they're infected. By shutting that down, the virus basically goes into stealth mode, making copies of itself without anyone noticing. So when you piece it all together, you see this absolutely devastating four-step assault. First, entry using that GP master key. Second, it goes dark, evading the immune system with its VP saboteurs. That leads to step 3, unchecked replication, where the virus builds a massive army of itself. And finally, that army spreads everywhere, causing systemic damage, especially to blood vessels. That's what leads to catastrophic bleeding and organ failure that makes this disease so deadly.
A terrifyingly effective attack, right? So how on earth do you defend against something like that? Well, you don't just build a taller wall. You have to create a complete defensive strategy. And that's exactly what the Ebola vaccine is. It's like a training manual for our immune system.
I absolutely love this analogy from the research because it just nails it. The vaccine strategy works like a two-pronged defense for a city. You've got a wall and gatekeepers to stop intruders from ever getting in, and you train specialized military units to hunt down any that somehow manage to slip through. And that is the core idea right there, a two-layered defense. The vaccine is so clever because it doesn't just teach the body one move, it prepares it for a total war, fighting on two completely different fronts at the same time. And here's exactly how those two strategies work. On one side, you've got what's called humoral immunity. Think of this as the wall. Its main target is the virus's master key, the GP protein, and its weapon is antibodies. The mission? Block the virus from ever getting into a cell. Then, on the other side, you have cellular immunity. These are the special forces. Their mission is totally different. Find and destroy any of our own cells that have already been infected.
Let's dig into that first layer. The vaccine essentially shows our immune system the virus's master key, that GP protein, but without any of the dangerous virus attached. Our body sees it, recognizes it as foreign, and starts producing what are called neutralizing antibodies. You can think of these antibodies as custom-made locks that are a perfect fit for that viral key. So if the real Ebola virus ever shows up, these antibodies immediately swarm it, jam the key, and make it completely useless. The virus is literally locked out.
But what happens if a few intruders manage to breach the wall? That's where layer 2 kicks in.
The vaccine also shows our body a few of the virus's internal proteins. This trains an elite squad of killer T cells. These are our special forces. They constantly patrol the body, and they have one job and one job only: to seek and destroy any of our own cells that have been turned into virus-making factories. They eliminate the threat from the inside, stopping the infection dead in its tracks.
So why is this two-layered approach so incredibly smart and effective? It's because it creates a defense that is both incredibly strong and incredibly deep. It leaves the virus with absolutely nowhere to run and nowhere to hide. This right here is the goal of modern Ebola vaccines. You want to generate a powerful response on both fronts. Not just a wall, and not just special forces, but a really strong response from both. This combined immunity is so much more powerful and long-lasting than either defense would be by itself. And what's really amazing is that this brilliant training manual can be delivered in a bunch of different ways. Think of these as different shipping methods for the same defensive blueprint. The approved rVSV vaccine, for instance, uses a totally harmless virus as a little delivery truck. But scientists are also exploring cutting-edge methods like mRNA and DNA platforms to teach our bodies this exact same two-layered defense strategy. So if there's one thing to take away from all this, it's this. To defeat a perfect intruder, you need a near-perfect defense. The whole goal is to create complete, comprehensive immunity. You secure the fortress by blocking the virus at the gate and having an elite force ready to eliminate any threat that gets inside. It's that simple and that powerful.
And that brings us to the final and maybe the most important question. We've cracked the code for Ebola. We get how it attacks, and we've engineered a defense to match it. So the question for the future is, how can we use this fortress defense strategy, this incredible two-layered approach, as a blueprint to prepare us for the next big threat? For the virus we don't even know exists yet. It's a question scientists are racing to answer, and it's one that really affects every single one of us.